This video is sponsored by KiwiCo. More on that later. There's a blue case sitting in the middle of the room, but strangely, you don't remember it being there at the start of your Nerf battle. The real question, though, is why is it opening and what's about to come out? If you said childlike wonder, you'd be right. But if you said a Nerf Nuke, you'd also be right. It's okay if you're skeptical. You have good reason to be. My first introduction to the concept of the Nerf Nuke was a comedy sketch. But maybe you're more familiar with the ThinkGeek April Fool's concept from over a decade ago, a sweet-looking but non-functional prop. Searching YouTube, you will find some working, albeit small devices, as well as this ridiculous foam fixture that managed to rack up almost 2 million views while doing absolutely nothing.
Rarely are there ideas so ubiquitous that they could survive and even thrive in our imaginations alone. Especially when those ideas could totally be built in real life, right? So even though I had already decided to build a real Nerf Nuke, I wondered if maybe I was missing something?
So on Friday, I published the algae video. On Sunday, my wife was due. She's not had the baby yet. It is Monday. For some reason, I can't stop thinking about the Nerf Nuke. I start to question with projects like this, why hasn't anybody done it? Unless it's actually really, really difficult.
Now, if it does turn out to be really, really difficult, I already know what the main issue will be. Maybe you do too.
After all, Nerf would be nothing without the ability to launch a dart. Or in our case, 100 darts, and all at the same time. But thankfully, back when I was breathing algae fumes, I had an idea. And now on Monday morning, that idea had me. The basic concept of this is to take some sort of a sphere or a tube and poke it full of holes and stick a bunch of darts in and then pressurize it. Right. This is basically how a normal Nerf gun works. A spring-loaded piston builds pressure until the dart is forced out of the opening. But that's just one opening. If you take a ball and you shove a bunch of darts into it and you pressurize that ball, they'll all go flying out, right? Maybe. You see, what happens is as soon as the first dart leaves, suddenly it's a low pressure zone and pressure can then escape through that hole, meaning that there's less pressure for the rest of the ball. Path of least resistance will go and then the air will all go out with it. So we just need a ton of pressure to make up for this, right? No. If there's one thing that my self-firing Nerf dart taught me, it's that Nerf darts are made of foam. If the pressure gets too high, they'll just burst or shred or pop. So instead of more air pressure, you need a way to stop air from escaping once a dart has gone. Well, that's why I bought all these syringes. And the way that these are gonna work, I gotta show you. Inside the syringe is a little plunger, which both creates and is moved by pressure. Now, if you take one of these syringes and drill a 1/2-inch hole in the end, two things happen. First, you've created a perfect snug hole for a Nerf dart. And second, you've still left a little rim of material that will stop the plunger from leaving the syringe.
And I bet you've figured it out. Instead of using pressure to push a dart out of an opening, we'll use pressure to push a plunger to push a dart out of an opening. And once that plunger reaches the end, it'll stop and no more pressure will be able to escape.
And the brilliant thing about using the syringe is that the syringes are cheap. I got 100 of these syringes, it was like $16. I'm very hopeful that I can make these work, and I think I'm gonna do some early tests by modifying some PVC pipe to make a little sealed chamber, pressurize it with various methods, and then see how far do the darts shoot. This just had to work, and I just had to see it. So I hit Goodwill, grabbed a used foam roller, stole some CO2 fittings off my old web shooter, and built a quick pressure chamber. Then I hooked it up to a CO2 tank, turned it on, and let her rip. And no matter how much CO2 I put into the chamber, I got pretty much the same result. Now, some of this is because it wasn't exactly airtight, but some of it was because of the sheer size of the chamber. Air is like a spring. A big spring takes a lot of energy to compress, and all the energy in this tank has to flow through a very small opening, meaning it will take a long time to reach high pressures. But the plunger will already be moving at the lower pressures along the way, and that's a problem. Imagine that you're trying to jump across a big gap. You want to be running as fast as possible, but if you've already reached the end of your running space before you reach top speed, you're just not going to make it. So in order for our plunger to have a running start and thus launch our dart as far as possible, we need to get up to high pressure before it even starts to move. It needs to get up to pressure very quickly in order for that plunger to move quickly. We need something like hydrogen that can immediately create a bunch of pressure because it moves so quickly. Oh, that's scary. I don't think I want to make little hydrogen. Now, it took a moment to process, but I had just had my second major eureka moment for this build. If I do it, then it's a Nerf hydrogen bomb, which is a type of nuke. This is like the sketchiest possible way to, oh my God, hydrogen is, this thing. You know hydrogen, that stuff that's been historically consistent. And while I wouldn't be creating a fusion reaction with hydrogen isotopes like an actual H-bomb, I would be using it as a simple combustible to create high pressures in a chamber, and there's a certain poetic consistency to it, among other advantages. For one, hydrogen can be created with a battery, the same power source as many Nerf guns. The electricity is used to split water into hydrogen and oxygen gases. But before I go building an oxyhydrogen generator, I decided to build a small test chamber so that I could experiment with a propellant that I already had on hand, flash cotton. Inside the chamber is a heating element, which ignites the flash cotton when you connect a battery to it. Now on the first test, I didn't use enough flash cotton. And the second one failed because I had glued the chamber to a foam surface. So instead, I glued it to a more solid piece of wood. Whoa! Oh my gosh! I can't even see the darts. They go out with such velocity, and the plungers shot out too. The two plungers that flew out probably escaped because they didn't have a solid core, preventing them from squishing out of the opening. So I put the plastic bit back inside of them. Well, that destroyed one of the syringes. You see, this plastic isn't the strongest, and those plungers have to come to a sudden stop.
Before we were worried about too little pressure. Now we're worried about too much. So I figured, why not try it without any plungers?
That worked really well. That was slightly less propellant than last time. The darts are sealing not at the back, but all the way at the tips. That's right. Because the seal is all the way at the end, pressure stays in the chamber for longer, and we are less likely to burst a dart because the highest pressure happens while the strongest part of the dart is taking the force of the differential. There's plenty of excess propellant. Maybe I'll try a really low power one and just see how it does. Well, that was pretty reasonable.
So whether hydrogen or flash cotton, it's rapid combustion that's going to push these darts. Possibly even without plungers, but we need more than 4 syringes to be sure.
Which means we need a basic nuke body design, and mine starts with an orange foam soccer ball.
My plan is for it to be the tip of the nuke body, which will ultimately look a bit like a Nerf missile when it's finished.
But I couldn't find a foam ball larger than 8 inches in diameter,
so everything in the body needs to fit within an 8-inch cylinder. And in the middle of that 8-inch outer cylinder needs to be an inner cylinder that acts as a pressure chamber, just like the bowl from our experiments.
So I want to go with the smallest possible tube that can still support enough syringes. If the diameter is small enough, then you can't really mount a lot of syringes. There's just not enough material to mount the syringes to. We want it to be lightweight, need minimal propellant, but also big enough to support enough darts.
Now, before we pick the perfect inner chamber, we should probably check in with my brother Charles, because he's been working on something pretty special.
So you need to press these both within half a second of each other, and then it opens up and the button comes up. Oops, you broke it!
Now, as you've probably guessed, Charles is working on the launch system. You know how in the movies they always have like 2 keys to turn and like a big red button that's hidden behind some kind of clear cover? Well, the whitest kids you know knew that in their comedy sketch, and even ThinkGeek incorporated some of those themes into their April Fool's prop. So this is a rough model of what will go inside of our launch control briefcase, also known as the Nerf football. It's funny that we're doing this because just building a working Nerf nuke is like enough of an undertaking. Like, I don't even know if I'm gonna be able to pull it off. Like, I will, because I always figure it out. But here we are, doing goofy shit. This case by itself is gonna be so sick.
It's gonna be really fun.
1, 2, 3. So big progress was being made on the launch system, which was good because I had just made some big progress on the propellant.
Oh, and I forgot I didn't show you.
Holy crap! What? Dude. What? I didn't even see them move, they were just gone.
Now, to understand what he just saw, let's pick back up where I left off in the search for hydrogen.
But as it turns out, I wasn't really looking for hydrogen, I was looking for oxyhydrogen, the output of an electrolysis-based generator. And this guy seems to know a lot about that.
So the output of an electrolysis device, if you take the output from both terminals, you end up with a perfect mixture of hydrogen and oxygen, the exact amount you need for the perfect explosion.
The perfect explosion sounds perfect, right?
I'm gonna be building a Nerf Nuke.
There's no way you could contain that explosion. When you're talking about supersonic explosions, that shockwave and the flame front of that explosion is actually traveling faster than sound. And so it actually can create higher peak pressures. It's not even reacting to the other side of the container that it's in because it's moving so quickly.
Now I know he sounds certain, but we all sometimes have initial reactions that are a bit hasty, and I really, really want this to work.
You're saying this as a concern. If I can ride that shockwave, could it just be that I need very, very little?
Huh. There are a couple ways that I could think that you would do this.
Now, the main idea was to separate out the hydrogen by itself for a less volatile reaction. But then he sent me links to these cleaning bottles with electrolysis units built in, and since their anode and cathode are right next to each other, you can't easily separate the gases, so I figured, well, let's just rig this up to generate oxyhydrogen, pump it into our test chamber, hide under the table. 3, 2, 1. Okay, I know this looks bad, but that was just the tiny bit of flash cotton I was using to make sure the oxyhydrogen ignited. The generation had gone well, but I'd only put 1 syringe worth in, and for good reason. After all, here's what just a few bubbles can do. 4 syringes. Whoa! 4 syringes was enough to get combustion. It wasn't enough to launch the darts completely. In fact, we got a fascinating cross-section. This one has just barely started to move. This one's like slightly over halfway. This one's almost exited, and one of them went flying. And as soon as this one went flying, the pressure stopped going and they had an arrested launch. This is a perfect illustration of the kind of problem that we're facing with this, where we need to have enough propellant to reach pressure instantly. Now, it took about 20 seconds to fill a syringe with oxyhydrogen, so I just started filling the chamber directly for a set amount of time. That was 2 minutes of hydrogen oxygen mixture in 3, 2, 1. Woo! So we got all but 1. 3 minutes of hydrogen and oxygen. Huh, look at this. Still not enough. We have our 4 minutes. Okay, that's a launch. This was huge.
I had a working oxyhydrogen generator and had proven that a syringe dart chamber could safely harness its power to launch darts. Well, to make sure that it was really safe, I decided that I was going to completely saturate the chamber with oxyhydrogen. And this time, I wasn't going to use any flash cotton because I wanted to see if the hot wire itself was enough to ignite the gases.
So I hid under the table just one more time. 2, 1. Yes! Too much power wasn't too much power. Well, at least not for the chamber to handle. Meaning, this seemed reasonably safe to move forward with for the main design. And that's what my dad saw when he stopped by for a visit.
Oh, cool!
And the video clip of my dad is what my brother saw when he was over at my house working on the launch case.
Holy crap.
What do you think?
Oh, awesome. If you can put that in your nuclear Nerf thing or whatever, I think that'd be awesome, man. Yeah. That's brilliant.
Now, since my dad was doing such a good job with the paternal validation, I figured I'd show him my plans for the core design, so let me show you too. So here's the setup. I just want to put a bunch of holes in this tube. That's it.
I had settled on an aluminum tube with a 2.5-inch outer diameter, and this would be the chamber that all the syringes mounted to, just like the bowl.
I mounted the tube to a stepper motor to make a basic lathe setup on my CNC machine and wired it into my X-axis. So now instead of my machine moving sideways, the tube would just rotate. Then I plotted a pattern of holes that were spaced evenly throughout the tube without running into each other, and this proved difficult.
You see, at first I was gonna have vertical rows of holes, which is very easy to place, but not very effective. Think about it. If you're looking down on the Nerf Nuke from above, if you happen to be standing in front of one of these rows of holes, you're gonna get hit with a bunch of darts. But if you're standing just off to the side, in between any of these rows, you're not gonna get hit with anything.
This slowly winding pattern ensures that the darts are spread out for optimal radial saturation. Now I just had to recalibrate my machine, babysit it for hours as it cut 100 syringe-sized holes, and hope that nothing went wrong.
Well, here we are. It's cut. I mean, I cut it Thursday night, and then my wife went into labor Friday morning, so here we are at Sunday afternoon, finally getting a chance to touch it.
And man, it was really nice to touch. Oh, I don't even want to use it. It's beautiful. This core would have a smaller tube make up the inner core, and this is where I would fit whatever launches the whole Nerf Nuke itself into the air before it detonates and launches all the darts.
So basically the gas will be trapped between the tubes.
Yeah.
So that's a smaller area that it needs to compress. And then through here is where the PVC pipe will be a good size. So just like whether it's a spring or gas or whatever goes inside of it.
I gotcha.
And that's the launch tube.
Now these 100 holes need 100 syringes, and each individual syringe has to be unwrapped, deplungered, cut, beveled, and drilled. That's 5 different operations times 100, and that's before they ever even touch the chamber. But it's my belief that there's a factory worker hidden inside all of us, and I certainly got in touch with mine. It was tedious work. I couldn't go too fast lest I crack a syringe. And I mean, come on, cutting them with a big chop saw, is that really the best way?
No, it's not, but it's what I got, so...
But eventually the clouds parted and I was left with the easy task of attaching them to the core.
I'm trying to fit the syringes into the holes, and I'm finding that, first of all, I undersized the holes so that maybe they wouldn't need adhesive, but it's a pain to get these things started, and then they do not want to come out.
Because these syringes are polypropylene, conventional adhesives like cyanoacrylate, aka superglue, don't really bond with them, so I designed the holes to be very tight, like press fit tight.
I think I figured out how to get this done without, utterly destroying myself. So, first of all, I got a nice little tape pad here. You take the prepped syringe, and first you want to grate the cheese, because you need to make a really big bevel. Then you want to take the heat gun, you want to give it about 4 seconds, just to soften the end a little bit. Then you want to line up the end so that it's just perfectly straight going in and lined up with all the edges. And then you're going to push with your palm as straight as you can, because if you deviate at all, and then you're gonna kind of wiggle it into position roughly. Being careful, because if you wiggle it too much, it'll just keep going in. It only goes in for some reason. It's like a ratchet. It doesn't want to come out. So it's actually moving along at not fast, but it's moving along.
Then the syringes had to be aligned, because even with perfectly spaced holes, they still had room to wiggle. And to be honest, I think my stepper motor lost some steps because some of these holes weren't actually perfectly spaced. And since the syringes could still wiggle a bit, I decided to coat the outside of the tube with hot glue, since its thick coating would help to lock the syringe positions, even if it didn't actually bond to them.
It should hopefully hold everything in position. After all the algae, I wanted something simple, and that's what I've got here. Just something simple.
Now we all want to see this thing shoot 100 darts, but that means loading it with 100 darts. So I'll play the loading footage 4 times faster than normal while I tell you about today's sponsor, KiwiCo. I've worked with KiwiCo before. They still make really cool kits for all ages, like this delivery robot that my older kid and I had a blast building. But they've got something new now, KiwiCo Clubs. It's designed to take you on a more comprehensive journey of problem solving. Their KiwiCo Labs Club, for instance, starts with science, moves to engineering, and then ultimately leads you into inventing. But they've even got things like KiwiCo Studio, which is focused on art and design, or KiwiCo World, which explores geography and culture.
The great thing about KiwiCo, whether for you or for someone else as a gift, is that its value goes beyond the physical objects that you create. Just like my projects, it's about what you learn in the process.
And the experiences that they've cultivated provide ample guidance to facilitate the growth of curious minds while they just play.
Give a gift that truly keeps on giving. And use code JOELCREATES to get 50% off your first club crate when you join a club for kids aged 3 or older. Or go to kiwico.com/JoelCreates. Thanks, KiwiCo. And that's how long it takes to load a Nerf Nuke. I gotta show my mom.
Hey Mom, You want to see something crazy?
Wow, that's a lot of work.
It looks really cool.
It does. If they were just up and down, that wouldn't look quite as, I don't know, I think formidable. You can see the movement. You have Mom's stamp of approval.
If you hear a bang,
Come and check for you.
no, everything's fine.
Now there'll be no bang without a fuse, but once that was installed, I gassed it up with oxyhydrogen, but that was having issues igniting, so for those first few tests, I decided to start with flash cut.
1.
That was one dart!
It smells weird in there. It looks like, I don't know if we just got incomplete combustion. Clearly we need a lot more. 3 times as much. Okay, 12 darts came out and several more loose. This time we're gonna do this much. 3, 2, 1. Whoa!
Now that was a pretty big bang, but it needed like way too much flash cotton, and I think the tube inside was just too large for either propellant.
I want to do hydrogen. I think I'm gonna put the old caps on there. Lots of gas. See if we get what we need. We can always put a smaller tube inside there for launch purposes.
So I removed the inner tube and put a new fuse in with some big caps on the ends, filled it with gas for 10 minutes, and here's what happened.
That was great. That was amazing. 83% of the darts launched, and we blew out the bottom. So as long as the bottom doesn't blow out, with a blown top now, 88%. If we can just stop the top and bottom from blowing out, they're all gonna go. We've reached a huge milestone in the Nerf Nuke journey. That's 88%, and that's with a blown top. Everything's looking really, really promising. It's been an interesting few weeks. I jumped right on this right after the algae video. Then, my wife had a baby. I don't have a boss to tell me that what I'm doing is right. I doubt myself a ton. I try and only put the positive stuff in the video, but the truth is that this is a constant mental battle. Man, now some of that might be my health issues that I have. I'm exhausted and my stomach hurts almost all the time. Just because you feel shitty, just because things seem shitty, it doesn't mean they are. And if you give into that thing where it's like, all is lost, then yeah. And if you start acting as if it is, then it will all be lost.
And the only all that will be lost for this project will be all these dang darts once this thing is fully operational.
Holy shit! What? What? Holy crap, that was horrifying.
What?
That was horrifying.
2 darts? 98%!
What the?
Finally, some real progress, but now we had to cross a pretty difficult bridge.
A big spongy blue bridge made of foam.
I mean, we can't exactly launch this core into the air and expect it to survive, and it doesn't look very Nerf-y at the moment either. Well, we already know that the tip will be made out of this ball, but cut in half. So, could we just find a foam cylinder and cut it to fit the sides? Not really. You see, most foam rollers are only 6 inches in diameter and made of a pretty hard polystyrene type foam. Plus, how the heck would I cut the inside of one to fit something like this? And then fill all the gaps in between? Forget about it. Thankfully, there are 2-part polyurethane foam kits that let you mix and pour colored foam into a mold, which it will expand to fill. So after I ordered some foam and blue dye, I got to work on a mold, and it's actually pretty simple. Rather than find a tube with an inner diameter that perfectly matches the outer diameter of the ball, I found this skylight kit used at a thrift store for a few bucks, and it's perfect. Not only can the diameter be adjusted, but it can then be unwrapped to make mold removal much easier. And to make sure it's the right diameter and perfectly round, I cut 2 discs out of melamine board. One disc mounts to the bottom of the Nuke core, and the other mounts to a PVC pipe that is stuck to the end of the other side of the Nerf core. This has holes in it to allow foam to be poured through and to allow any excess to flow out when it expands. Now once they're mounted, the metal skylight sheet just wraps around it. But I feel like we're missing something, or 100 somethings. You see, the syringes don't reach all the way to the ends.
If they did, then they would probably break if this thing ever came down from a launch and landed on its side. So they're recessed in about 1 inch from the edge of the mold. Now, we can't just pour the foam in yet, because if we do, it'll go into the open syringes and it'll block any opening for the darts and it'll ruin all of my hard work.
Well, that's where these pink caps come in. They fit on the ends of the syringes and will touch the outer wall of the mold so that they can be pulled out and the remaining voids cleaned up after the molding process. Of course, each of these 100 caps has to be dipped in mold release first, and the walls have to be coated with it, and the discs, and the PVC pipe. The lower seams of the mold will also get hot glued to prevent leakage, because this foam starts as a viscous liquid. You mix one part with the dye, then you mix the other part in, and quickly. You only have it like 1 minute before it starts to expand. Now, because they sell this by weight, and because I hadn't designed the nuke fully when I bought it, I didn't know I wouldn't have enough until I did some basic volume calculations just before I poured it, and realized I wouldn't have enough. So I quickly ordered more, and decided to change the mold by modifying a funnel to create the cone-shaped nuke bottom. This will save some foam, and I won't have to cut it into this shape like I originally planned. And once I mixed the second batch of foam and poured it in, I was relieved to see that there was enough for it to spill out of the opening. And a couple hours later, it was finally time to crack this bad boy open. I was so psyched.
Dude, I'm so psyched.
Oh, wow.
Look at this. Would you just look at it?
Dude, that looks kind of cool. Now, because I did it in 2 parts, the finish wasn't as even as I would have liked, but I cleaned it up as best I could and began the ridiculous process of removing all 100 pink caps. Some of them I could see, but for some, I just had to sorta guess. But eventually I found my rhythm and perfected my technique. And once they were all removed, I was ready to clean up the holes with a conical sander. I was ready to clean up the holes with a hole punch. I was ready to clean up the holes with a hole punch that's been heated up and carefully inserted into the existing pocket and then has its melted edges hand trimmed with a razor 100 times. But eventually there was room to fit 100 Nerf darts and then dangle this thing from my ceiling.
Right now, this is filling with hydrogen. When I pull this out of the bottom, there'll be a slight delay, and then it'll go off. This is also probably the safest launch that we've had, because not only do we have 100 foam safety valves, but the whole thing is covered in foam. There's just no way that whatever goes on inside of here is gonna harm us. It just physically cannot. 3, 2, 1.
So the first test had not enough oxyhydrogen.
Oh, man.
And the second test still didn't have enough. And the third test still didn't.
3, 2, 1.
Woohoo! That's all but one.
Look at that! That's it! How did it sound?
It sounded loud.
That's 99% efficacy. And this dart was right on the cusp of coming out. That's 99.9% efficacy. And once the cap's on and once the whole launch system is put together...
Now there's something pretty crazy about the detonator system at the center of the Nerf Nuke and the silo launch system that it will interface with, which of course will be controlled by that really cool launch briefcase that we've been working on.
But that, and the full field testing of the total Nerf Nuke system with people, is gonna have to wait until part 2.
Oh, hey, I'm Quincy. I'm the handsome camera operator who makes all control such. Dude, this is...
You can't show it. You have to hold it a little longer.
Wow, your face is so greasy.
I think that'll do.